All right, so we are back. Oops, I'm not even on the right spot. We are doing 6.8 called signing and co-signing it. And it's a solidifying understanding, which means that you're familiar and we're going to practice a bunch of stuff. So the very first part is a notice and wonders. Describe at least 2 things you notice and 1 thing that you were wondering about as you examine these. So go ahead and do that. We'll talk about that tomorrow as well. And so by the end of today, you'll be able to find a relationship between the arc length and x comma y coordinates of a point on the circle of a radius of 1. And how does the unit circle, that's what the circle of radius 1 means, we'll call it the unit circle, makes our work with trig functions easier. And I will say this is one of my favorite things to talk about is the unit circle, because I don't know, it just makes a lot of sense. Okay, so here we are. Oops, I'm trying to scroll with my mouse and it doesn't work. It says, in the previous lessons of this unit, you have used the similarity of circles, the symmetry of circles, right triangle trig, and the proportional reasoning to locate stakes on concentric circles. Concentric means like they have the same center. So think target, the target logo. In this lesson, we consider points on the simplest circle of all, which has a radius of 1, which is often referred to as the unit circle. So here's a portion of a unit circle, the portion lying in the first quadrant of the coordinate grid. As in the previous lesson called staking it, this portion of the circle has been divided into intervals measuring pi over 8 radians. As done previously, find the coordinates of each of the indicated points in the diagram. Also find the length s from the point 1, 0 to each of the indicated points. Do not use a calculator as you label the coordinates or arc length. Instead, leave your answers as fractions or as trig expressions, exact values rather than decimal approximations. Okay, so what we're going to be doing is we're going to kind of do what we did before, except for now we're just reminding ourselves how to do it so we can get into this, right? So we want to, say again, you want to find the coordinates of each of the following. So they basically want you to go here and say what comma what. Okay, what comma what. So if you remember, I'm just going to draw all over this guy. So I'm going to draw this right triangle, take the elevator down to the x-axis. And because this is pi over 8 here, right? Pi over 8. You also know they told you that the radius is 1. So this is 1. And so if you look at this, if I wanted to find the x coordinate, here's my x, right? And you look at this right triangle, you're like, oh, I can either use the Pythagorean theorem or SOHCAHTOA, the trig functions. And obviously right now I can't use Pythagorean theorem because I need to know at least 2 sides, and I only have 1 side. And so I'm going to use sine, cosine, and tangent. So in order to find x, I'm going to use cosine because that's the side that deals with the adjacent side. So here I'll write the equation cosine of pi over 8 equals to x over 1, which is just equal to x. So x is just cosine of pi over 8, right? So then I'm going to write that here. Comma. And then similarly, I'm going to write sine of pi over 8 equals to y over 1, which is just y. So that's sine of pi over 8. And you're like, oh, look, that makes sense, right? And then I'm going to continue doing this using pi over 4 and so on. So go ahead and pause the video and find me my coordinates for pi over 4, pi over 2, pi over 8, 3 pi over 8, all of them by using your triangles to distinguish that. Okay, so now that you're back, I am going to find all these with you. So I'm going to just kind of do it like this. And I'm going to go, this is pi over 4 over here. And then I take the elevator down. This is x. this is y, this is 1. And you're like, oh, Ms. Johnson, it looks exactly the same. So cosine of pi over 4 is equal to x over 1, right? Adjacent over hypotenuse, which is x over 1. So x here, in this case, is just going to be cosine of pi over 4. And you're like, hey, Ms. Johnson, I noticed a pattern. Good job. Continuing on, sine of pi over 4 is going to be this similar. It's going to be y over 1, which is just y. So that's just sine of pi over 4. And so you're noticing a pattern. Hopefully you're noticing this pattern. Maybe I shouldn't have used y here because that y is that y. So that's okay. I'm going to do the similar thing to that. I'm just going to erase all my stuff so I don't get you all confused. Take the elevator all the way down. Right, this is x, this is y, this is 1, this is 3 pi over 8. Right, and it comes out to be exactly the same. So cosine of 3 pi over 8, comma sine of 3 pi over 8, right? And if you notice, for this one didn't go right or left, so we just went straight up. So this guy is 0, comma 1. So hopefully this makes sense. And if it doesn't, go back and do some of the reminding you of what cosine, sine, SOHCAHTOA are so that it makes sense to you. All right, moving on. It says repeat the labeling of the points using a calculator and then work with the work you did on the diagram previously. That is, x and y coordinates are arc length, so they should be given in decimal approximations. So now what I'm going to do is I'm just going to pull up my graphing calculator. And then I'm going to go over here and I'm just going to write, so here, so I'm going to go functions. I'm going to hit cosine of pi over 8, right? And then it's 0.924. Now, some of you are thinking, Ms. Johnson, you didn't hit the degrees button. I shouldn't, because pi over 8 is measured in radians, right? So I am going to write this as 0.924, comma, and then I'm going to do the sine. Similarly, I'm going to do sine of pi over 8, and I get 0.382 or 0.383. Okay, so go ahead and fill the rest of these in as I do this, and then come back for the answers, and then I will show you. Okay, so now that you're back, I'm just going to erase these and put pi over 4. So this is 0.707, and this is pi over 4. And you're like, hey, Ms. Johnson, those are the same. That makes sense though, right? Because a 45, 45, 90 degree triangle, the x and the y are going to be the same, right? It's an isosceles triangle. So that makes sense. Okay, so I'm going to do the next one, which is 3 pi over 8. So 3 pi over 8 is going to, oops, that's my y. So let's do 0.924. And then let's do this down over here. This is going to be 3 pi over 8. And that's 383. Okay, and then this is going to be the same as 0, 1. Okay, so there goes that. Okay, the next part. So it says, hold on a second. Okay, so it says Javier, let me move this out so I can read better actually. So it says Javier has been wondering if his calculator will allow him to calculate trig values for angle measured in radians rather than in degrees. He feels like this will simply simplify much of his computational work when trying to locate the coordinates of the stakes on the circles surrounding the central towers of the archaeological site. After consulting his calculator's manual, Javier has learned that he can set his calculator in radian mode. Now he's ready to examine the following calculation. So you already know this because you've done it. So with your calculator set in radian mode, find each of the following values and then record your answer as decimal approximations to the nearest thousandth, right? So let's do that together. We already figured out sine of pi over 8. Let's just look at that again. So sine of pi over 8, and that's 0.383, right? So I want you to go ahead and fill all of these out based on your calculator. Make sure that you're set in radians. Right here, it should be set to radians. If it's not, that means you need to go back and fix it. Okay. And then come back here and then just check your answer. So here, all you're doing is you're plugging stuff into the calculator. So you'll come back and I'll have everything all filled out for you. So come on back when you're all done. Okay, so now that you're back, I filled out my chart just like you did. And then there are my answers. So just verify that you did that. If you got one of them wrong, figure out what you did wrong to figure that out. The next part, it says the coordinates and arc length you found for points on this unit circle seem to be showing up in Javier's computations. Why is that so? Right? So So the coordinates and arc lengths you found for points on the unit circle seem to be showing up in Javier's computation. So why is that so? That is, explain why radian measure of an angle on the unit circle is the same as the arc length. Right? Why are they the same? And then the next one is explain why the sine of an angle measured in radians is the same as the y coordinates. So if you drew out your triangles, that should make sense to you, right? When we were doing this over here, right? And then similarly, y is cosine that. So hopefully that makes sense to you. So I'm just going to explain these answers. So this one would make sense to you because when you did it, it was opposite over hypotenuse, but your hypotenuse was 1, right? So the sine of that angle with the hypotenuse of 1 is going to be the same as the y coordinate. Right. So if you remember when we were drawing out our triangles, it looked like this, and this was our y, and this is 1. So whenever we had our angle, whatever that was, whether this be pi over 4, the sine of pi over 4 was going to be y over 1, but y over 1 is just y. So notice the sine of the angle in a circle with radius 1 or hypotenuse of 1 is going to be the same as the y coordinate. So similarly, it's true for the cosine for x, right? That makes sense because your hypotenuse was going to be radius of 1. So you were divided by 1, which is the same thing. So why was the radian measure of an angle on the unit circle the same as the arc length? Well, that's because the radian measure is the ratio of arc length divided by radius. Remember, we did that in one of the lessons. It was the arc length divided by the radius, but the radius is just 1. So that means the radian measure is the same as the arc length, right? Okay, next one. Based on this work, find the following without using a calculator. Find the sine of 5 pi over 8. Find the sine of 5 pi over 8. Okay, so when I find the sine of 5 pi over 8, the thing that I like to do is I draw them out a little mini like crossbar, and I look for 5 pi over 8. So if you remember, this is 0, and I want 5 pi's over 8. So I'm going to go back to this picture here where this was, now I'm just going to count by pi over 8. So this is pi over 8. This is 2 pi over 8. This is 3 pi over 8. Whether you realize it or not, this is 4 pi over 8, right? If you simplified that, do you see how pi over 2 is the same as 4 pi over 8? So can you imagine that 5 pi over 8 is this guy out here, something like this? You guys all see that? Okay, so I'm going to draw that. So 5 pi over 8 would look something like, I don't know, something like this, right? And then, so again, you're doing this whole drawing this. Oops, let me do that in a different color. So you're going to draw this whole right triangle, right? Where this is going to be y and this is going to be x. And you know your radius is 1. And so if I was looking for this, right, the sine of this guy is going to be this y coordinate here, which if you remember the Carlos thing, when he was on the Ferris wheel, you guys remember how it matched this one right here? Right? So what is this angle right here that it matches? The y is going to be the same as this, right? So let's see. Let's look at that picture. I'm going to flip back up here. So see, it would match this if you kind of like took the circle out. It would be right here, right? So that matches with 3 pi over 8, right? So this guy here, this is 5 pi over 8. And then, so it's going to be cosine of 5 pi over 8 and the sine of 5 pi over 8. But you already know these because this guy, the y's are the same, right? If you draw that triangle in, those two heights, these two heights are exactly the same height. Remember, this is something that one of you observed when you were on that Ferris, or when he was on that Ferris wheel. And the x's are just in the opposite direction. So if I wanted to find that, can you picture this with me? I would use 3 pi over 8. I would use this information here to find it. So it would be exactly the same. So this would be 0.924. And then write yourself a little note. Like, I know this because it's the same height as 3 pi over 8. Right? And I'm not using the cosine because I don't care about the x. They didn't ask me for the sine of it. I mean, they didn't ask me for the cosine of it. They asked me for the sine. So similarly, how would I figure out 7 pi over 8? So if you go back to your picture up here, so that's 5 pi over 8. Where would 7 pi over 8 be? So hopefully you said it was this one. I'll try to draw it in pretty well. This one, right? And then if you continue the circle this way, you kind of see my like funny looking circle. But it's the same. The sine of this guy is going to be the sine of who? Who does he match up with? Yeah, he matches up with pi over 8. So if in my picture, I just need to find the sine of pi over 8 because that's going to give me that one, right? And so if you think about cosine of pi is 8 pi's over 8, which would be all the way on the opposite side. It'd be this guy. So they wanted to know which one? The cosine of pi. Oh, shoot, I did it wrong. They wanted cosine of 7 pi over 8. I did this wrong. Hold on. I wrote the sine of pi over 8. Sorry. So I should have used this guy, the cosine. Oops, I'm erasing. So I should have used this guy, the cosine, because that's what they asked for. So that's not correct. Let me fix this. So this should have been 0.924. Right? Except for we're not going positive, right? If you look at this guy, he's on the negative side, right? Like this is, if you look at this, this is on the negative side of x. So I'm going to change this sign to be negative. Okay, so write yourself a little note, right, while you're doing this. I would write something like, this is the same as cosine of pi over 8, except negative. And the reason why it's negative is because it's going in the negative direction. And then if you want to think about cosine of pi, I'll just draw a quick picture here. So pi would have been this guy here. So they're asking for the x coordinate right there. And because my circle has a radius of 1, it would just be -1. So this is just -1. Okay. Let's continue. So again, if this doesn't make sense, go back to your original picture and notice all of your symmetry between those. So why are radians important enough to have their own mode on a calculator? Here are some things to think about. We've defined radians as a ratio of arc length to radius. If the arc length and radius are both measured in meters, centimeters, inches, or feet, what are the units of that ratio? Right? So if you think about it like I don't know, if you said like, I want to know how many oranges. So let's say I have 6 oranges and I'm dividing it into groups of 2 oranges each. So if I had 6 oranges and I was dividing it into groups of 2 oranges in each group, I would have 3 groups, right? So interestingly enough, there are no units on this ratio because they're the same. So it's almost like, can you think about the units canceling as well? So number 7, if we define radians as the arc length of an intercepted arc on the unit circle, x squared plus y squared equals 1, how does the length of the arc that measures 1 radian of the unit circle compare to the length of the 1 unit on the x-axis? So an arc that's measured with 1 radian on the unit circle would also be measured 1 real number unit. Okay, it would be the same. So 1 can measure angle. Oh, sorry. Explain why what the statement means. Radians are important because they measure angles using real numbers instead of degrees. So how does this make sense? So can you imagine like a tape measure, right? So the reason why a tape measure is called a tape measure is because it measures the waist of a woman or a man. It measures the length, like it measures basically a curved length. And so when, if you've ever made anything, if you use this curved tape measure to go all the way around something, and then you want to figure out, well, how long is that? You can almost like lay that out like this and see how long it is, right? Okay, so next part. Since we can think of real numbers along the x-axis of a radian measure of an angle of a rotation, we can graph sine and cosine as functions of x. It helps to label the x-axis in a way that highlights real numbers that represent a full rotation, a half rotation, or some other useful fraction of a rotation. The following are 2 examples. So graph each of the following functions on the grids provided, 1 function per grid. And be prepared to explain your graph strategy when you chose and why you chose to graph this. So go ahead and graph 2 sine x and sine 2x. So you're going to think about these numbers, these values here, 0, pi, 2 pi, and you're going to graph sine 2x and 2 sine x. Do you think these are going to be the same? Maybe, maybe not, right? So go ahead and plug some numbers in and see what you get. I'll show you how I graph it because I want you to see how to do it. Yes, you can use Desmos, but you need to make sure that you understand how to graph sine and cosine, okay? Okay, so now that you're back, so when I graph 2 sine x, so this is going to be f of x here, right? And this is equal to 2 sine x. So the way I do this is I'm just going to plug 0 in. So I go 2 sine of 0. And what is that equal to? So when I plug in 0, what do I get out? Right? So if you think about 0, right? 0 is right here. And we've learned that sine is really just the y coordinate. Okay? So this sine value of this point is 0. So this is 2 times 0, which is just 0. So it's this guy right here. Okay. The next guy I'm going to plug in is this pi, and you'll see why in just a second. So again, I'm going to plug in a pi, which is over here. This is where pi is. And I'm asking for that. So that's 2 sine pi. So again, I'm looking for the y coordinate on that. That's still 0. So this is still 2 times 0, which is just 0. So this is going to be 0. And you're like, Ms. Johnson, this doesn't look like a very good graph. And the last one I'm going to plug in, I'm not last one, sorry. The next one I'm going to plug in is 2 pi as well. This is 0, and this is also 2 pi. And again, it's a 0, so that's just going to be 0 again. And you're like, Ms. Johnson, this doesn't look like a very good graph. And you're right. So now I'm going to plug in the people in between there and see if I can get any information. So I'm going to plug in this guy up here, which is called pi over 2. And I want you to focus because this is sine. I'm looking at the y coordinate. So the sine of this guy is going to be 2 sine of pi over 2. The sine of pi over 2, the y of this guy, so this is asking you this. What is the y coordinate? So the y coordinate here is going to be 1, right? Because this is 0, 1. So this is 1. So this is just 2 times 1, which is 2. Okay, so this is 2. So pi over 2, 2. Similarly, I'm going to plug in the guy downstairs, this guy down here. This is 0, 1. So that's 2 times -1, which is just -2. Oh, that's what this curve looks like. And then this is called 1 period, right? This right here is called 1 period. So this is just going to repeat over and over again. It's going to go high, middle, low, middle, and then high. It's just going to keep repeating that same pattern. So sometimes when I graph these, my curves don't look so curvy. They look like really funny. So if yours look funny too, that's okay. But it's supposed to be a curve. It's not supposed to look like a bunch of V's. It's not the chevron pattern for those of you who are familiar with that. It's not V's. They're not mountains. They're like curves. So that's what that looks like. And I'm going to do the same thing over here with sine of 2x. Okay, and I'm going to use the same numbers that they gave me here. So I'm going to start with 0, and I'm going to plug 0 in here. So I get sine of, oops, that says 2 in, sine of 2 times 0, right? So that's just 0. So sine of 0, what's the y right here? That's a 0. That's fine, right? Not a big deal. Not a big deal. Then I'm going to plug in pi. Oh, yeah, I'm going to plug in pi. I'm going to skip around a little bit. I'm going to plug in pi, so I get sine of 2 pi, right? And 2 pi is all the way over here, so again, that's 0, right? And you're like, Ms. Johnson, it's doing that thing again. I know. That's okay. So then I'm going to plug in pi over 2 to see what's happening here. So I'm going to plug in sine, let me change colors, sine of 2 times pi over 2, which 2 times pi over 2, these cancel. So now I'm looking at sine of pi. And this guy right here, the y coordinate of this guy is 0. So Ms. Johnson, it's 0 again. And you're like, yeah. So guess who I'm going to plug in? I'm going to plug in the people between those two, which is pi over 4. right? So I'm going to plug in pi over 4, which it's sine of 2 parentheses pi over 4. And if you simplify that, that's the sine of pi over 2, which is this guy, right? And what is that guy? What's the y coordinate of this guy? And you're like, oh, Miss Johnson, it's 0, 1, so it's 1. So I'm going to plug in 1. So he's right there. And then I'm going to plug in this bottom guy, and I bet you he's down here. So let's try that. Sine of 2 parentheses 3 pi over 4. And so these two cancel, leaving a 2. Wait, what was I doing? Oh, yeah, that's 3 pi over 4. Sorry. And that's 3 pi over 2. And so the y of this guy is 0, negative 1. So that's negative 1. So look at this picture. Let me see if I can do this. And look at these two differences. And so there's two big differences you should see. And I don't know if you can see it. But the first difference that I noticed is this guy, the amplitude goes as high as 2 and as low as negative 2. This amplitude only goes as high as 1 and as low as negative 1. The other thing I noticed, to complete a full cycle, it took 2 pi long. It went from 0 to 2 pi and it completed a cycle. Here, it completed a cycle from 0 to pi. So those were your big, like, what is happening, Miss Johnson? What are the big things that we were supposed to get out of that? And so now you should be a lot more comfortable with, like, understanding this. The biggest things that I would want you to take away, and actually let me go through takeaways and then I'll talk about the takeaways I want you to know. So the next part, it says every point on the unit circle gives the sine and cosine values of an angle of rotation, because the arc length of an angle of rotation measures the angle of rotation in radians. Okay. And the x coordinate is the same as the cosine, and the y coordinate is the same as the sine of that angle. So that's all I really wanted to share with you. Have a great day and see you on the next video.